FiRM is very unique.
We get to do something very innovative.
FiRM is converting wood poles to steel poles.
So I've seen it evolve over the years.
Now on the FiRM project, we're building things. We have a track record.
I've always been a fan of leading edge technology and being able to work closely with the advanced SCADA deployment.
There's a lot of great things that come out of FiRM. It's creating a lot of standard ways of construction.
It's very refreshing and nice to work with people that are very passionate about their job. Big things that we're doing in FiRM is fire mitigation, obviously, which includes converting wood poles to steel poles and using fiberglass crossarms instead of wood crossarms. It's a new construction tactic or strategy for us. One of my responsibilities on FiRM is to oversee the design, the structural capacity utilization, the PLS-CAD. So one of the strengths associated with PLS-CAD is due to this more accuracy doing this nonlinear analysis, it allows us to perhaps elongate and optimize the life of these assets that we're installing. So we're not shooting for just a 20 or 40 year life, we're really trying to optimize to the 80, 100 year perspective.
There's a lot of collaboration in FiRM with other departments, including distribution operations, distribution planning, distribution engineering, space, system protection. So coordinating all of that input from those stakeholders to make sure that we're building the best distribution system possible and getting their input. It's interesting to see how each of their feedback goes to building that better system. Some of the feedback we've provided them and some of the comments we've seen in the field, especially with some of people that have worked at FiRM, have had 5 or 6 years experience programs. That valuable experience is getting back to those departments to better standards and to better understand some of the challenges they face and how we can fix those going forward.
One of the great benefits of the RFI process is it allows us to identify systemic errors or things that are recurring and allow us to talk with standards or distribution or transmission to identify things. Hey, this has come up a lot. Perhaps there's ways we can improve this, approach standards, and improve this in the future so that this doesn't recur in the future.
DPSS, the design unit catalog, and SAP. So we're dealing with a lot of different programs. And then we have our standards on top of it. And our standards is really the center point of everything.
And my first rotation with the company was in standards, and it's very interesting to see outside perspectives, almost as if you're now engaging a different audience.
But the location is actually harder to find on distribution than you would imagine, and especially on the FiRM program where it's in the backcountry. There aren't a lot of roads. There might be cover from the top, meaning like trees or shrubs, so it's hard to pinpoint using GIS where that pole is. These photos and this LiDAR data, something that maybe we could use for environmental purposes for FiRM, I realized potential. And then I found out that we could go one step further, which is to embed that information within a GIS layer.
Part of the FiRM program includes the as-built process, which includes doing post-construction LiDAR and identifying what the in-situ condition is. Where is our actual conductor sagged at relative to what we specified in construction? When we do quantify this, we're able to develop these PLS-CAD models, which tell us the in-situ condition and also provides us the most up-to-date information for future reference. So if anything changes in the future, then we could very quickly reference these models and change things as necessary.
So with LiDAR processing, our UAV or helicopter, it's flying around in the air and it's shooting out lasers in a very, very simplistic way of describing it. And we need to know to a very, very just micro level accuracy of where that UAV was at every single moment, 200 times a second, 200 hertz, so if it was pitching down, rolling to the right, rolling to the left. All these little things are adjusting where those lasers are getting sent out. The beauty of LiDAR data is it is vector data. So it's future-proof, it's time signatured, so it's historical.
A large part of why we were brought into the project was to create a more efficient workflow. A lot of the FiRM project is little one-offs here, little 2 to 3 poles at a time, not entire circuits. So to mobilize a helicopter crew wouldn't be inefficient. We can still cover anywhere from 10 to 12 miles in a flight. So in a given day, with 3 flights, which is typically what we average, you can get between 20 and 30 miles worth of data or it's still just as efficient to only get 5 miles of data.
So having these tools from FiRM could lead to some serious efficiencies in our world, in environmental, which translate into less time and money. We don't have to go out in the field to do the surveys. And then we can give our answer to FiRM faster.